Hey everyone, welcome to our GoEngineer Houston office. You're gonna say something? Your name?
Hello everybody, my name is Gonzalo Krosnyak.
And I'm Tony Riggs. We're here today for our 3D printing utilization within the oil and gas industry webinar. That's kind of fun to say. There's no question that oil and gas industry is a huge part of everyday life here in Houston. We're kind of biased that way, we think. So this is why Stratasys and GoEngineer kind of tasked us to dive a little bit deeper into this industry to find out about, how is 3D printing being utilized. So to help us find out more, mainly Gonzalo, but we created a survey that we sent out to all our oil and gas contacts. And with the findings of that survey, we created a white paper that tries to shed some light on the role of 3D printing in this industry.
That's right.
So in this webinar, we're going to present and then discuss some of our findings. So Gonzalo's going to move over to his laptop to monitor the chat. So make sure to type any questions into the chat and we will try to cover them at the end of the presentation.
Perfect.
And then he'll maybe give me some little messages to, hey, talk about this or talk about that. We'll go for there.
Let's go.
Okay, so we're going to switch over a little bit. Okay, so the oil and gas industry is a fairly mature industry that exploded in the early parts of the 20th century. We looked up, the oil boom started in like 1901. So since then, the oil and gas industry has been an early adopter for new technologies, and it's been a cradle of innovation, using 3D CAD, 3D printers. So, it's no surprise that we see 3D printers deeply rooted in the entire process in the oil and gas industry. So there's a number of different technologies under the 3D printing umbrella. The two technologies that are most used, at least what we found in the survey, is fused deposition modeling, or FDM, and stereolithography, SLA. That's kind of one of the original 3D printing tools. So it isn't a surprise that the more mature forms of 3D printing are showing up in this mature industry. So the survey indicated that the most common place for 3D printing utilization is in the creation of jigs and fixtures and functional prototypes, and then followed closely by maybe display and presentation models. So we're going to take a look at some example applications for each of those technologies that we mentioned. For jigs and fixtures, we see that the FDM technology provides a quick, easy, inexpensive way to iterate and deploy solutions for everyday, say, shop floor problems. We found applications in production, assembly tools, QA, quality control, inspection tools, on into packaging and logistics, even health and safety, making tools that make common repetitive operations, easier to do. So there's been many times when we've gone out to install a machine with a customer, and they've identified a singular application to justify a printer. And by the time we go back to visit them the next time, they found so many more applications where they're using the printer. We see 3D printed parts all over the shop floor, and you're going to find multiple examples listed in the white paper. So we're going to make sure that everybody gets a copy of the white paper at the end of the presentation, and you can dig a little bit deeper into the results that we saw. So what about functional prototypes? One of the benefits that we always preach for in-house printing is that you can run multiple versions of a prototype for testing. maybe you have five different solutions you want to try. If you had to send the parts out to be prototyped, you might only have to select one version to test because of time or cost. So that's always been a big benefit of having a printer in-house. Well, it's kind of interesting. Within the last couple of years, with everybody working remote, we've seen an interesting shift here and there. So instead of printing one design to hand around a conference table, we're not at the same conference table. So we've seen companies printing multiple copies of the same part or assembly and sending them out to everybody's home to handle, and then come back with maybe a Zoom design review where everybody can hold the part in their hand. So the idea of having a 3D printed part where you can come in and test it out and see, how is it going to work? Is it going to fit together nicely? How are we going to machine a component can really play a big role into, the usefulness of 3D printing. So functional prototypes is a big deal. This is a display model also that we've got, in our office. So just another application for where you can take things. So more iterations, more copies, being able to generate, feedback from the entire team and make a better design in the long run. Maybe once we get to the final stages in the design process, technology like stereolithography could also provide higher resolution, smoother surfaces, finer detail for that finished prototypes. So customers also look at SLA for size and speed, and also a little bit more for material selection. For SLA, one of the big applications that we've seen a lot is the idea of printing investment casting models with the SLA technology. Okay, so it's just another one of those applications that we look for different technologies, and we've seen multiple times where a company having just one technology doesn't quite cover all the bases. They may have an FDM printer or an SLA or PolyJet. Having multiple technologies isn't a bad thing. The third most common application for printing, at least what we're seeing from the survey, is display and presentation models. So maybe we have the design finalized, but we need to promote and sell the product. So PolyJet technology can aid in producing detailed, accurate scale models in full color. Maybe we have options for a flexible material or a clear material, and just all at the press of a button. We'll talk about that process a little bit later on. But how do we take a part and see it on our computer screen in CAD and then be able to print it? Without 3D printers, how could we create these parts traditionally? It might take an army of machinists and artists, carpenters, all kinds of other different kind of categories where one or two of these technologies can come together and complete the task fairly easily. So the software that powers most of the Stratasys printers is GrabCAD Print. It takes native CAD files like SolidWorks or STEP. We're not just exporting an STL file every time. One for every iteration. If we've got multiple STL files and then keeping track of all that, it can be based on the native CAD geometry. So that's a big time saver and data management saver. So GrabCAD is a very powerful and straightforward tool that's very easy to control and operate, and it's a nice tool to help even monitor our 3D printers. You know, when the print is done, getting a text message or an email from the system, you know, telling it it's done, or hey, we need more material in the printer, or you know, some even have, you know, built-in webcams to monitor the print as it's go. So just orient the part and hit print. It's usually that easy, but we'll talk about that a little bit later on. So we talked about how FDM and SLA are the most common technologies. We talked about the most common applications where 3D printing is found, but you know, is 3D printing really working for everyone? Does it really help? And are you satisfied with the results? Those are some of the questions that we asked in the survey, and it was pleasing to find that the results came back that most customers are very happy with their 3D printers, very happy with the material options that they've got, and then the 3D printing workflow in general. There are a couple places where you might want to see some improvement. It might be in the post-processing side of things. So it's kind of funny that I wrote this down. The white paper has a quote in there that says, successful support material removal from the 3D printed part is vital to part quality, and it's what enables complete design freedom. So we see a lot of the home printers or hobbyist printers where we're using model material to help support the model. For most of the printers and materials, having a water-soluble support material that's easy to remove. You know, if the part is too fragile, am I going to break the part, or can I just put this part in a cleaning tank to remove the support material or the resin, etc. Can really help save the day. You know, we can definitely print parts that if you had to manually remove the support material, it would be very, very difficult to do. So very delicate features is a nice thing to capture. So post-process and support material removal have always kind of been an afterthought, but it's really a core factor in the success of the 3D printed part. Finding the fastest printing orientation is not always the best orientation. Orientation can determine strength, aesthetics, speed, you know, print time, material usage, as well as support material usage and removal. We've seen cases where, you know, the support material maybe has to be removed, you know, manually. We were at a customer that couldn't have water in their facility, so we helped them with some techniques through the software to change the support strategy, the support material generation strategy, to make it where we could remove the supports manually. It's like, well, don't you want to have a tank? You can put it at your house, and then you not have to deal with the regulations there. But they were surprised, and we were happy that we were able to help them really make, you know, the support removal process, even if they had to do it manually because of their situation, it was possible. So in the white paper, there are some links for different post-processing tools and techniques that we offer through a company called Post Process or Dimension. There's multiple ways of getting rid of the support material, the resin, or the powder from the parts. And a lot of times we see that it's more about education and training. Oh, I didn't know to do that. I visited a customer once. They said that Man, it's taken forever for our parts to get cleaned. So we're having to take a ladle and we're moving the stuff out of the way, and then we're putting the part into the solution, and it's like, okay, time out. Once you hit pudding state on it should be, okay, I always say it starts off as water, you put some powder in that kind of makes it white. I kind of call it skim milk. Then it goes to 2% milk, and kind of by whole milk, it's about time to refresh the bath. They'd gone straight on to pudding. It was pretty bad. Visiting one customer, there's typically a purge bucket in the back of the printer. It's like, I know I told you about this because I was the one that installed the printer when they first got it. And I went back and they were having an error message. Well, the purge bucket had filled up, overflowed into the bottom, and it was covering up one of the sensors in the bottom of the bay. And it's just a matter of cleaning that out. So, we get that question all the time, how hard is it to clean a part? With some of the technologies, the polyjet material, has a kind of a gel support material. And so, take off and break off what you feel comfortable with. Same thing with FDM and some of the other technologies, and then use the tools, kind of that set it and forget it kind of thing. We also preach trusting the technology. Typically with a home printer, you're sitting there watching it and monitoring the whole time. With us, we've got 3 printers in the room next door. There's multiple times where I'll leave it printing, overnight, over the weekend. Kind of my biggest worry is, storm coming through and knocking the power out, or oops, Tony forgot to put enough material in to make it, last through the weekend. And it'll, like I said, it'll message you and let you know, when that time is up. With the survey, we ran into some interesting results as far as who was using 3D printing and who wanted 3D printers. And it was kind of happy to say that there was several that were saying that, hey, we've got one and we're really looking to expand, and so part of it's trying to figure out, okay, what do I just need 2 of the same technology, or what can I do to expand into one of the other technologies? So that kind of leads us into the next topic here. What about the future of 3D printing, or additive manufacturing, or rapid prototyping, whatever you want to call it? In the past few years, though, we've seen some major advancements in material selection, and that's bringing us to the future. With the FDM, we saw where the ABS material and the ASA material are kind of the go-to materials. There's 10 or 12 other materials easily on the FDM side of things, whether you need higher temperatures or chemical resistance or flexibility. There's options there. So thanks to some of these new high performance materials, 3D printing is expanding into manufacturing and production. It's not just for prototypes anymore. With the expansion of Stratasys printers into stereolithography with the Neo series, the new SAF technology with the H350, or P3 technology with Origin 1, we're bridging that gap into production. We can print, tens to hundreds of parts at a time and really, help out with that. If we've got supply chain issues, we're seeing that all over the place where people can't get the part. Well, let's just 3D print it. So GoEngineer is hopefully your one-stop shop for all of your additive manufacturing needs. So along with Stratasys, we also represent Exact Metal and Velo 3D for metal 3D printing solutions. So it's a question we get all the time. Can you print in metal? And sure, the metal powder is a great technology for, had somebody ask me, what's the heat deflection for stainless steel? It's like, well, that's usually not a number that you really look at, right? It can definitely handle that increased temperature and stress. We still see parts like the nylon 12 CF on the FDM side replacing aluminum machined parts. The weight, off gassing, whatever you need for your application, right? So, thanks for joining us today. We're going to make sure everybody gets a copy of the white paper with some of the survey results. And as always, if you have continuing questions, feel free to reach out to us. We want to help you with these technologies. That's that education thing. We want to be your mentor. Or let us try it first, and then I'm not afraid.
We'll break something.
We'll give it a shot.
There's one question coming in.
Okay.
It says you were talking about post-processing and support removal. And it says you mentioned that PolyJet is a good option for display models, but isn't support removal mostly very messy and complicated with PolyJet?
So like I said, for FDM and PolyJet, I usually like to break off what I feel comfortable with just a spatula or it's almost calming sometimes. I've taken stuff home, let my kids clean stuff. Maybe not PolyJet that much, but take off what you can. The initial support material for PolyJet wasn't water soluble. You would actually power wash it off with a power washer. You can still do that to get the bulk off. But I ran a part just the other day that was so delicate that I just set the whole thing in the tank. So there's tanks that have flow or ultrasonic, or there's some support material now that's just totally plain water soluble. You can put the delicate part in the tank and let the support material just kind of dissolve away. So for us, it's kind of we talked about it being an afterthought. We don't give it a whole lot of thought because we know how easy it is to do.
It's easy to do, yes.
And so it doesn't worry me too much. Sometimes you got to plan for it. But
we always encourage our customers to get the proper tools, right? And that will make the process that much easier.
Yeah. And like I said, there's been a couple in the last week that, they didn't have a tank, or, or we can't have it in this building. But we're going to put it where we don't have water in that room. So we have to haul the parts to a different room to clean up. There's all kinds of different techniques to solve those problems. Different solutions, different tanks, etc.
That's it. I don't have any other questions.
No more questions from the chat. I'll look over here on mine and I don't see anything that that's come in. Do you have any other finishing thoughts that you'd like to give?
No, thank you for attending. It was great, Tony. Good job.
It's been kind of interesting to dig into, what the oil and gas customers have been doing. Usually, prying information out of them is kind of fun. They'll talk to you when they're happy sometimes, or when they're mad about something. Hey, I'm out of material on a Friday afternoon. I need to print some parts. They'll ring your phone then. But it was, for those that did respond to the survey, we thank you for your contribution to our data.
Yeah.
And we look and watch that.
That's it.
Uh,
So we're gonna email everybody the white paper and the survey, so you can get all the information and go over it. It's really, really good stuff in there.
well, I was going to say have a great weekend, but it's only Wednesday. Is it Wednesday?
Maybe a long week.
I'll see you on Monday.
Thank you very much.
Take care, everyone, and we will talk to you at the next webinar.